KLSQ 870 AM. Whitney, Nevada. 5 kilowatts non-directional daytime. 430 watts directional nighttime. Day power and pattern is non-directional. Same amount of power in all directions. So one of 3 tower is broadcasting. The center tower irradiates close to same amount of power in all directions. Factor into rain and land conditions and pattern will look something like this. Now, for night operations, FCC requires to lower power, in this case to 430 watts, and modify the shape of the RF pattern, so KLSQ would not interfere with other stations at 870 kHz. To modify the shape of the RF pattern, we use 3 towers. 1, 2, and 3. By putting more or less power into each tower, the RF pattern is then modified.
Now, this electrical power has also an electrical angle, so by placing the right amount of power at the right amount of angle into the right tower, we get a mathematical pattern that looks like this.
Overimposed on a map and factoring terrain then looks something like this. Notice the nulls or places where the signal seems to be lower. Those indicate the change in pattern, so by placing radials and measuring the signal strength along those radials, we check to see that RF pattern is within FCC requirements. The signal strength is mathematically predicted along those radials. So by selecting a point along the radial, we should know what the signal strength should be, and those are the monitor points. Now, on that radial locator map, the points are kind of crowded, so let's see them on Google Earth with their respective coordinates. Monitor point 1, monitor point 2, monitor point 3, monitor point 4. And here are their coordinates, and a brief description on how to get to them. Now, during the November 2014 inspection by Nevada Association of Broadcasters, it was determined that 2 of the 4 points were off. This meant the pattern has been altered. Here are the results during that inspection. One possibility was the addition of the large array of solar panels on the side of Highway 93 as part of the Nevada Solar One project, and its installed power lines. This would have implied filing to the Federal Communications Commission for modification of the license, where the new monitor points and their new levels are explained, and a whole level of hassle. Hence the other stations at 870 kHz must be protected. Fortunately, the issue causing those monitor points to be wrong was much simpler, and it went back to 2 crucial elements. 1. Potomac monitor antenna system at transmitter site was reading wrong values. 2. Phaser at transmitter site needed to be adjusted so right power at right angle is then injected into each tower. So Potomac antenna monitor system at transmitter site was fixed, but still it was not possible to get the right amount of power at the correct angle into the towers, specifically the corner towers. The reason: there was also some copper loss, stolen a few years back. at the base of each of the corner towers, so the grounding at the tuning boxes was not appropriate. Then, once the copper was restored, then the phaser could be adjusted. So finally at transmitter site, values were adjusted, as per Federal Communication Commission License Authorization Information Sheet. This translated into the proper values at the monitor points, as follows. One of the challenges is accessing the monitor points, though by side of the road, some roads are remote. The following 4x4 excursion was videotaped going from monitor point 4 to transmitter site. Rest assured, no humans or innocent trucks were hurt in the filming of this video. Once these monitor points have been adjusted to proper values, a report has been submitted, and we are now expecting the Nevada Association of Broadcasters to emit the respective diploma passing the inspection, as we have with our FM stations, KISF and KRGT. Thank you for your attention. We hope this presentation has been informational. Any questions, please feel free to contact our Chief Engineer Manny Garcia. Regards.